2.5, this is derivative rule number 10, section 2.5. This is called the chain rule. Now, before we talk specifics of the chain rule, I need to remind you about a little bit of algebra that you may have not thought about in a while. And this is the idea of composition of functions. So the chain rule is for derivatives of composition of functions. So composition of functions often involves this little circle symbol. And we'd say f composed with g of x. And the way that we would write that would be that we would nest our functions. So we'd have f of g of x. So as an example, I might look at the function capital F of x is equal to the quantity x squared minus 1 raised to the 4th power. So when I look at this function, I can see this x squared minus 1 raised to the 4th. I can interpret that as a composition of functions. So we can see f as a composition of functions. And so when I look at this, what I see here is I see an inside function, and that's like my g of x function. And so x squared minus 1 is my g of x function. And then if I kind of think of this x squared minus 1 as a blob, well, I'm taking that blob and raising it to the 4th. So my outside function is my f function.
That's supposed to be a minus up there?
Here?
On the other one.
This should definitely be a minus sign.
Oh.
Yes, thank you. That's supposed to be exactly the same as what's inside the parentheses over here. Good, thanks.
Make sure.
Okay, so my outside function, the one where I've got this blob inside, which has a minus sign in there. I've got this blob inside here. Well, that's raised to the 4th. So I'm taking my blob, which I'm going to call u, and raising it to the 4th power. So I have two functions going on here. And so when I write down little f of g of x, well, what I'm really writing down is, okay, f of g of x, everywhere I see in my f function, everywhere I see a letter u, I'm going to replace that with my g of x function. So I've got f of x squared minus 1. And so f of x squared minus 1 is x squared minus 1 raised to the 4th power. Okay, so a major goal in this chain rule portion is going to be to look at functions that are made up of a composition of other functions, and we want to be able to pull them apart. They're nested together, and we want to be able to identify the inside and the outside function. Here's another example. We've got a function, capital F of x is equal to sine of x cubed plus 5x. Now, when I look at this function here, I've got sine of stuff, and this stuff is inside of parentheses. And so my inside function, that's my g of x function. So we'll say that g of x is x cubed plus 5x. And then the outside function, we're going to call that function f of u. We're just picking a different letter other than x. Now, f of u, well, that's sine of stuff. And so our f function is sine of u. So we've got our inside function and our outside function. And so now if I write down f of g of x, and I put them back together, well, first I have f of x cubed plus 5x. And our f function is sine of u, so everywhere that I see a u, I'm going to replace that with x cubed plus 5x. So I've got sine of x cubed plus 5x. Okay, are there any questions questions on either of these two examples, x squared minus 1 raised to the fourth, or sine of the quantity x cubed plus 5x, any questions on piecing apart the inside function versus the outside function?
Are you picking a different letter for that, just for clarity?
I'm picking a different letter for clarity. This could certainly be an x here as well. That would be fine.
So your final answer would just be that last part?
This right here? Well, yeah, let me try that again. So the goal here was to take this function and pick it apart into its inside and its outside function. And then we tested our choices of inside and outside by putting them back together to get back our original.
Okay.
So this last part was kind of a check of our choices for inside and outside. Thanks for asking that. Okay. Okay. All right. So now that we've looked at two examples where we've taken a composition of functions and picked it apart into its composite pieces, I'm going to write down the chain rule. And here's what the chain rule says. The chain rule says if f and g are both differentiable functions, and capital F is f composed with g, then capital F is also differentiable and capital F prime is given by capital F prime of x is equal to, and pay close attention to the notation here, capital F prime of x is equal to little f prime of g of x times g prime of x. Or, an alternative way of thinking of this, an alternative notation here, is if we allow y to be f of u, and u to be g of x, then dy over dx is equal to dy over du times du over dx. Okay, so let's look at this rule a little bit more carefully here. So there's a lot of stuff going on here. The first comment is, and this is kind of a big deal in and of itself, and we pretty much take this for granted in Calc 1, and it's not really until you hit something like an advanced calculus class where you really focus on this idea. But if you have two functions that are both differentiable, little f and little g, and you do a composition of functions, then that new function that you get is also differentiable. So that's good, because you can take two functions, put them together, and build a new complicated function that is still a differentiable function, still smooth, there's no corners, there's no cusps or anything like that. And besides that, that's the part that we end up taking for granted a lot in here. And not only that, but we now have a formula for that derivative. And so one way to think of this is this f prime of g of x times g prime of x. And the second notation down here looks a little bit less cumbersome. And in fact, if we think of these as fractions, it almost kind of makes sense because the du on the top and the bottom kind of cancel each other and it gives you dy over dx. So this is saying that the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. All right, so when I think of the chain rule, I tend to not really like to memorize formulas with a lot of symbols, and I tend to remember things in words. So this is how I think of the chain rule. When I think of the chain rule, what I say to myself is derivative of the outside, keeping the inside the same, times the derivative of the inside. Derivative of the outside, keeping the inside the same, times the derivative of the inside. Now when I go back to this first version, the formula that has the f and the g in here, well, I'm taking the derivative of the f, which is my outside function, keeping the g of x the same inside, times the derivative of that inside function. All right, so let's take a look at an example.